Okay, hello. Can see a few of you out there. Thanks for being here. Always appreciate when at least a few of you can make it for the live stream. So thanks for that. Um, Hope you've had a good start to your week. We're in week 7, so we're motoring right along. I don't have any lab demos for this week, but I had projects to grade in another class, so I will thank your class for doing such a good job on all of your labs. The lab work was really, really solid last week, so I'm grateful for that because the easiest my grading life can be is when you do great work. So I appreciate it when you do great work, and it's also happy for me when you guys do great work because I think you like to get the good results, and I like to see you get the good results. So anyway, hopefully that continues for us. All right, so let me get into one of our sections and zoom it a little. So where we are in week 7, which means that you need to begin looking at the second project. And I know that this is one of those things about computer science or project-based classes that can be a pain when you are in school, that there's never a moment during the semester when you probably shouldn't be working on a project. In addition, of course, to all the regular work that we're doing to build our toolkit. So week by week by week, we are adding more tools to our toolkit, and that gives us the ability to solve more complex problems. And hopefully you're starting to notice that our problems are becoming more complex. We're actually, this week, writing code that actually solves actual problems that people sometimes in school, sometimes other places want to be able to solve. And we can do it now in a computer. So that's exciting to have. Next week, we add the ability to make decisions, and that would be if a certain situation exists, we do one thing, otherwise we do something else, at which point we can start really digging in on the second project. So I strongly encourage you to go look at the second project now, or at least this week. Set up a REPL for it if you want, and kind of do what kind of setup you can, and then be on the lookout because next week is when we get a lot of a new technique that allows us to do a lot of the work toward the second project. So anyway, be on the lookout and you'll be better positioned to take advantage of the new techniques that we learn during the week on the project if you already know what the project is about. So anyway, that's why I would recommend it. Let's look at the content. I'm pretty sure I can just, I'll go quickly over to a REPL and start looking at some code things, but let's go through the content anyway and just see what to expect. So we're going to be using some new packages this week. So you've probably lost track of it at this point, I suspect. We have been using the FUMPT, FMT, or format package all semester long. What that package contains is, I'll call them routines, but in Go they call them functions. It contains functions that are meant to assist us in handling input and output. So we have FMT or FUMPT.printf, which assists us in formatting and printing things to the screen. We have FUMPT.scanf, which assists us in reading different data types from the keyboard. And then we also used last week FUMPT.sprintf, which was a way to format a string in the computer's memory so that we can move it around between different components in our software. What that looked like simply was that we used FUMPT.sprintf to return a formatted string from one function to another function. So we've used a package all semester long. We're going to add 2 new packages today that are kind of related. One is package math, which has a whole bunch of functionality in it to do higher orders of math, more complex types of math, as opposed to what we do with the basic plus, minus, times, divide operators, mod. And then also the math rand package, which will give us the ability to introduce random numbers in our program. And the reason why we want that is because we're going to be making a couple of small games on the second project. And They are games that will play against the computer, and so we want random numbers so that the computer can appear to play randomly, driven by these random numbers. Okay, so 2 new packages, and then we will continue talking about functions, passing and receiving parameters, returning values from functions. This is one of the more difficult things to get used to. In my experience, and this is my personal experience as a student when I was doing computer science, and also my experience having taught computer science for a long time now, 23 or 24 years overall. Most people can figure out how to make these things work before they can explain them well, before they internalize the concepts in their head. They have figured out how to make them work in their programs, and that's okay. You begin to identify patterns. You begin to identify situations that look familiar or similar to other situations that you've dealt with, and then you take advantage of those patterns and repeat them and make small modifications so that your new the new thing you're trying to do works. And then at some point you will begin to internalize how functions work, what it means to call a function, what happens when I pass information to a function as in the form of parameters. On the function side, what the parameters are used for, and then finally the hardest one, which is how are these return values working? For now, you just need to recognize when the parameters are there and when the function is supposed to be returning something. And that's usually means 4 things. A function that accepts parameters has something you have to do on the side of the function, but a function that accepts parameters also means that there's something that you have to do on the side of calling the function. And then the same thing for functions that return values. You have to do something on the side of the function to deal with the return value, and you have to do something on the side of the calling the function to deal with the returned value itself. I have a variety of ways that I have discovered that help me explain it to myself. You'll come up with your own ways of explaining it to yourself. I personally like to think of functions as kind of people who talk to each other, who share information back and forth between themselves, but that technique may not work for you. Anyway, I appreciate that dealing with functions is difficult. When you encounter a problem and you need help on a function, it is very difficult for me to offer help to people who don't give me a specific situation to deal with. So when you're asking for help on a lab or on a project, direct me specifically to the thing that you need help with. Not the concept, which is harder for me to help you with, but a specific part of a lab. And then I can direct my energies toward helping you around that specific problem. And the labs are a good place to do that because the elements are numbered. The functions have names, so that usually gives us a place where we can orient ourselves. All right, a lot of words. So readings as always. Let me pop open actually package math and package math rand, so we have those available to us. They're going to look kind of scary at first when we go look at them because they are the official technical documentation of these things. But you practice and you learn to read them, just like you practice and you learn to read anything in any field of study. So when you go into the psychology class, they have their own terminology. They have their own notation system. They use the Chicago style for annotating or whatever it is, right? They have their own style. So we do the same thing in computer science. We have our ways of documenting and annotating things, and it just takes practice to learn how to read it. Homework as always. The lab, so I'll come back. I'll just kind of stage the lab and then come back to it. So the lab is unit tested. And I don't know how many times I actually ran the unit test last week, but My guess is about 10 different times. So I'm always saying this at the people who are at the live stream or watching the video. But if you know someone who has asked the question, like, I don't know how to do the test part, please direct them to the video because we have repeated it many times, and 99% of you, is more like 96% of you, got all that stuff and did great. But we have a small number of us who might need help kind of being drawn into the lecture to see those examples. Anyway, I'll come back to this page and we will, before we close, I'll see if there's anything to give you tips about. The discussion this week is about random numbers. So it is kind of something to learn about as a topic, the idea of random numbers and random number generation in computing. This has a variety of applications. If you've ever been to a casino, you are surrounded by random number generation. Every slot machine is a random number generator. And in fact, shuffling a deck of cards, rolling a die, spinning a roulette wheel, those are all means of generating random outcomes. And there are sort of different levels of quality of random number generators. If you work in the gambling industry, then you want the highest quality of random number generators on your slot machines, because if you have a poor quality random number generator, people can cheat and steal money from you, which is debatable whether or not it's cheating if they just figure out how you're generating your numbers. But the point is, it is a thing that is of interest to people in computer science. So the discussion is to ask you to go out and do a little bit of research on random number generation in computing, because we're going to be doing a little bit of it. You'll find the idea of a pseudo-random number, which is what computers produce generally, which is different from a pure or true random number. So I'm looking forward to reading your posts on that, because it's an interesting thing to learn about. And a lot of you play computer games, so you know all about RNG. Or if you play D&D, then you know about the dice rolls, which are a variety of ways of dealing with random number generation. Okay. And then among the reminders, so homework is always, lab is always, discussion is always, and then project 2 is due October 23rd, which is not very far from now. So this project cycle is, I don't remember how long it is, 5 weeks or something. But anyway, we're already running out of weeks. So the time to go read that is now. The time to start your REPL for it, I would argue, is now. Even if you have a REPL and it is completely empty of code other than welcome to project 2, that's okay. But you want to read it. You want to know what the problems are in the second project, so that when I give you tools for your toolkit that can be applied to the project, you will immediately recognize how you can use them. If you've read the project, you may know that you are getting one of those tools this week. Okay, so that's where we're at. I have math up. So let's go look at math first. And then we will go spin up a REPL and do some math things. So this is the page. Let me make sure you still see it. Yeah, so this is the page. Let me blow it up. For the math package in the Go language. So this is we call them libraries, although in Go they call them packages. But it's a library of functions. It's a variety of functions that are there to do, in this case, slightly more advanced math operations than the basic operators provide. So learning to read this documentation. So we can start sort of at the top of the page, and you can see that this is math. It is a package, and it is part of the standard library. When it says standard library in programming, that means that the installing or working in an installed environment of Go already has the standard library packages in it. There are non-standard or third-party libraries, and those have to be manually installed after you have a working Go environment. So math is a standard library package, which means that it is already available to us in our REPL environment. And there's some licensing and versioning information at the top. We don't really hugely worried about that. Let's scroll down. I like the way the page, by the way, I don't know if you saw it, but now it says Go Math, which is kind of slick as I scrolled down. So the overview, package math provides basic constants and mathematical functions. Constants you are aware of, no doubt, from math class. Pi is an example of a mathematical constant, and in fact, pi is one of the constants that is defined by the math package. A constant in programming simply means a value that cannot be changed, which is what pi should be. And we'll find the constants here in a bit as we go down. Okay, so let's look at the functions. There is a link to the constants, but we'll just get to those by scrolling down over time. So we have an absolute value function that accepts a single float as a parameter and returns a float as its return value. So if you call math abs function, give it a float, you get a float back. You can probably imagine that the float you get back is the absolute value of the float you pass in. If you pass in a positive float, you get a positive value. If you pass in a negative float, you get a negative value. In fact, let's just try it real quick. So let me get a REPL for this. Go REPL. CSCI 20, week 7. Okay, so we are going to add the math package. So the way you add an additional package or gain access to an additional package in Go is you add it to your list of imports. So notice what I've done here is I've stacked them. So fumped, and then on the next line down, math, which is good Go language style. But let's use it. So let me give myself a float. I'll just call it F1, be a float 64, and I will make it be equal to, let's just say 1.1, and then I will make a float F2, which will be a float 64, and I will make it a negative 9.25. And then we will experiment with it. So let's give ourselves a result float, and then we will use that to compute a couple of absolute values just to get a feel for how the math package works. So I will flip back to and remind you that we are in the math package, which is important. That's why I added it to the list of imports, and we're using the abs function. In fact, I'm going to click this link. So here is more detail on what the abs function does. Returns the absolute value of x. So when it says the absolute value of x, you need to inspect it to see what that x is referring to. Oh, the x is the parameter. So if I give it a parameter that's a float, I will get the absolute value of that float back. And then it's got some things dealing with this plus minus infinity is infinity, which is not a good thing in programming. You don't want infinity. And this NaN means not a number, and that's also a bad thing in programming. So in some error conditions, you can end up getting infinity, and maybe not 1,000% of the time is infinity an error, but generally we should not be experiencing infinity unless we have an error. Not a number, that's usually a bad thing as well. So we don't expect to encounter these, but they are documented. So NaN means not a number in programming. The inf means infinity. All right, so math, function abs, give it a float, get a float. All right, so how do we do that? So math dot abs. So the function is capital ABS. It is in the math package, which is why there's a math dot in front of it. It says I give it a float, so I'll give it F1. And then it says I get a float back. It returns a float. So when you are calling a function that returns a value, you need to do something to receive or accept or hold that value that's returned. So I call math.abs, I pass it my F1 float, and then I use the equal sign and another float to receive the returned value. Since the returned value is a float, I need to have a variable that is a float to receive it. So this to me is a conversation between me in main and this function somewhere out there in the world. So this is how I see it. It may do nothing for any of you, but I'm just telling you that this is the trick of the mind that I used to finally internalize these concepts. So I thought to myself, well, let's just say I had a friend and their name was math.abs, and if I wrote a number on a card and gave it to them, they would flip it over, write their answer on the other side of the card, and then give it back to me. That's how I learned to picture it in my head. So here's my friend. I've written F1 on one side of the card. Somewhere out there, they do their work to get the answer, and then they hand the card back to me with the answer written on the other side. That's what I'm doing with the result equals. So I'm not saying that will work for you. I'm just saying that I experimented with all these ways of explaining it to myself, and I finally found one that I could sort of make sense of this situation. You may be able to deal with a more technical explanation than I did. But anyway, if I call the math.abs function and I give it a float, what I need to do is handle the answer that I get back, which is also a float. So result is a float, result is a float. I am assigning the answer I get to my variable result. So then I can say, I'll do a fancy printf for this. So math.abs. Notice I'm just printing the letters in quotes, so it doesn't do anything. But I can do something fancy with this. I can say 0.1f. And then I'll point an arrow, and I will say %.1f. Put a new line. And then I'll plug into the first spot my F1. And I will plug into the second spot my result. So if I run this, I'll see the absolute value of 1.1 is... it's complaining about F2. I'll comment that out then. So the absolute value of 1.1 is 1.1. Let me make this 2 decimal places just to be safe. Let's try the same process on F2. So now I can put F2 back and I will use it and not get a complaint. So I'm going to reuse result. This time I'm going to use it to receive the answer that I get back from asking math.abs to work on F2. And then I'm going to cheat and copy and paste this print statement, changing F1 to F2. Result stays there because I have overwritten the result with now the answer I get back from doing math.abs on F2. So as we would expect, I think the absolute value of negative 9.25 is positive 9.25. So there is an unsatisfying example of the math package using abs, but it was the first one, so I tried it. You can imagine what some of these are. So acos is the arc cosine in radians of x. We're not going to do anything that fancy in this class, but just to show you that that kind of functionality in terms of math is available in the Go language and offered by the math package. So a cos h, arc sine. You can kind of see arc tan. What is CBRT? Cube root of x. Okay, I'll bite. Give it a float, get her float. So let's do a cube root just for fun. CBRT. So this time I'm going to say result. I'm just going to keep reusing result. I don't need it for anything, so I'll just keep using it to receive my answers from the math package functions. Capital CBRT. I will give it something that should have a cube root. And then I'll print that out. Math.cuberoot of 27. So I didn't use a variable for the parameter this time. I just used a constant float or a literal float, and that's fine. I'm allowed to do that. In fact, I'll put 27.0 just to be slightly more obvious. And then the answer is going to be, I'll do it to 2 decimal places again. Let's see. Oh, I only have one whole now because I just hard-coded the 27, so I just need to show the result. 3.00 as expected. So you can imagine there's a lot of these. There's a ceiling function. Returns the least integer value greater than or equal to x. It's a rounding up function, right? So, but the ceiling should take 1.1 and turn it into 2. So we're going to go ahead and try a few of these and just see how they work. So equals math.ceil. I'm going to reuse my F1 here, which is still 1.1. And then I'm going to cheat and copy and paste, even though this is likely to make me make an error. That is math.ceil. Put this back. And then printing out F2 and result. Hopefully none of the print statements is anything weird to people. I'm just trying to be literal about what I'm showing on the screen so I know exactly what I'm looking at. So I literally put math.ceil in the output and the parentheses. Oops, I put F2. That's supposed to be F1, so the printout was just cuckoo stuff. Anyway, so the ceiling on 1.1 was 2, and that's what the math package told us was going to happen, is it was going to give us the next integer value greater than or equal to it. So it rounded it way up. We did ceiling, copy sign. That has 2 things in it, so I'm not going to worry about it. Cosine. What is dim? The maximum of x minus y or 0. I don't know a utility for that one off the top of my head, so I'm skipping it. Error function. Those of you who are into higher math will see things that hopefully are kind of exciting. Exponent. So exponentiation, in other words, how do we raise something to a power? So let's do that. Result equals. So let's just raise, let's see what the arguments were. Oh, no, I don't want that. That's e raised to the x. No, yucky. I'm not using that one. That's no fun at all. Float 32 floats from bits. Floor, you can imagine. So the greatest integer value less than or equal to. Ceiling and floor can be very handy sometimes. You can round up and then clip something off to be an integer, or round it down and clip it off to be an integer. Can be super, super handy. But I also don't want to spend the rest of our lives looking at these things, just so you can kind of see all of the different things that are available to us. Logarithm stuff. Max and min. So max takes 2 floats and returns a float. And notice the xy in the documentation is referring to the xy in the parameter list. So we return the larger of the 2 variables. All right, so that one we can do. We'll do max between F1 and F2. Do I still have this? I do. So the max of, now I'm going to have to print 2 things. So %.2f comma space %.2f is f, and then it was F1 and F2 and the result. So max requires that I provide 2 floats, and the answer that I receive and hold on to is the larger of those 2 things. Remember that F2 is negative, which means that the positive number is the larger of the 2. There's also a min, which I'm just going to quickly do it this way. So you can see just a whole bunch of different math package function call examples. So the minimum value, the smaller of the 2, was negative 9.25. I will go back here and get back in the list. Min mod. That is a modulo for floats type function. Pow is handy. So raises, so notice that raises x to the y. which can be very handy to be able to raise an x to the y of it. So let's see how that works. And in this case, I'm just going to say so math.pow, and I'm going to raise 3 to the power of 3. Those are floats. And then print that out. Oh, I lost my little thingy. Pow. Don't need these guys anymore. I'll just print them out, literally. Nice. Yeah, so Kevin K has already probably did the math in your head already. We should expect to see 27 if the universe is still in proper working order. So good one, Kevin. Yeah, let's try it out. So it is, in fact, 27. So nice one. Math.pow. Useful. It's useful this week. There's a rounding function. So the difference between, so ceiling and floor are going to top up or top down. Round is going to do the thing that you're accustomed to, which is the halfway point. So you can experiment with round to see what happens at 1.4, 1.5, and 1.6 as examples and see what rounding does. There is a little example link for round in here. So it's showing you what happens to, if you do math.round on 10.5, you get 11. So 0.5 goes up, and no doubt 10.4 goes down. Yeah, you can also, I think, interactively alter these inside of the Go documentation. So I'm going to change this first one to 10.4 and run it. Yep, so 10.4 went down, 10.5 went up. This is also pretty neat for playing around with these things because they've already set up, in some cases, a little program that you can run in the documentation itself. Pretty darn slick. Sine, square root. This one's handy. So you can give it a float and it will return the square root of that number. Super handy this week. We have a problem, I think, where we need that somewhere possibly. Tan, and then some weird truncate. Anyway, so there's all the functions. Now let's go find the constants. Here's the constants, and I'll show you how these work. So the constants are everything in this list. So we have the constant e, pi, phi or phi, square root 2, square root e, square root of pi. So there's a constant for the square root of 2, I guess. Square root phi or phi, log 2e. Anyway, the one that's useful to us this week is pi. So the way you use that in a program is you simply say f math.pi %.2f, new line, math.pi. So you literally just put math.pi, and that is a stand-in for that actual value, which can be printed or done or shown in math. So there it is. I formatted it to 2 decimal places. If I take that off, it will run out much further probably. So here it ran out pretty far. I wonder if I can, like, how far will this go? Can I do it to like 20 places? Let's try. I can. I don't know how far that goes, to be honest. I can probably guess, but okay. So anyway, there's a constant. The one that you need this week is math.pi. So that's the math package, and some examples of how you use it. Now let's use the random package. So I'm going to comment these out and just do another whole program separate from that, and then I'll combine them later or something. Okay, so there's package 1, the math package. I'm also going to comment this out and restore it later as needed. The second one we're going to use is math rand. It's kind of a weird looking package name, so be it. But let's go look at rand. This is how you get it in your program and see what it is about. So here's rand. It is a package. It is in the standard library, meaning any standard Go installation environment is going to have it, like our REPL. I love this scroll effect. Look at that. That's pretty slick. I had to steal that. That idea is cool. Okay, so what does this package do? It implements pseudo-random number generators. So a pseudo-random number is not a truly random number. It's actually it's a generator that generates a series of numbers or a sequence of numbers based on an algorithm. And the problem of a computer algorithm is that it cannot be random. The computer algorithm has to produce the same results from the same starting spot every time. So that's why we call them pseudo random numbers. And then we use a variety of tricks to kind of make the random numbers look more random than they actually are. And the way we do that, if you were to run, well, I'll just do it. Let's get ourselves a function and we'll do it and then talk about how it's a pseudo random number generator. So the ones that we like this one. So rand.int, and what does it do? Notice, by the way, it takes no parameters but returns an integer. So that's important. I don't have to give it a parameter, but I need to receive its answer. Returns a non-negative pseudo-random int from the default source. What's the default source? I don't know, and I'm not going to worry about it until it affects me. So non-negative pseudo-random int. Well, let's try it and see what we get. And I'm just going to do a whole bunch of them. So f random number. These are integers. And then I'll just use the function right here in place. So what happens in a situation like this, where you call a function kind of inside of something, is it has to kind of work its way from the inside out. So if you call a function from the inside of some other parentheses, this function has to basically execute and then leave its result sitting there so that whatever is around it can use it. So when this line of code executes, it has to go from the inside out. So it's going to execute this function and leave an integer sitting there. And then what happens next? Well, now this function can take the integer that was sitting there and plug it in where this %d is. So from the inside out is how this happens when you nest functions inside of each other. Let's run it and see what we get. A very large number that I'm told is pseudo-random. What if I run it again? Same number, same number, same number, same number. That doesn't seem random at all. Let's try it like 5 times. 2, 3, 4, 5. What do the numbers look like? All right, so I'll just kind of look at the first 3 digits of each one. 5, 5, 7, 8, 6, 7, 6, 1, 2, 4, 3, 3, 9, 1. 4. It's the same numbers over and over again. So this is the problem with pseudo-random number generators. They will generate the same numbers over and over and over again. So, and they will generate the same sequence of numbers over and over and over again. So if I were to run this random number generator 1,000,000 times in a row, I will get the exact same sequence of 1,000,000 numbers every time I run it. The fancy computer science word for that, by the way, is that the algorithm is deterministic. But what you need to know is a random number generator can only generate one sequence of numbers, and it's always the same sequence of numbers. So Kevin K asks in chat, can I put anything in the parentheses and get a more reasonable range of numbers? Not with int I can't, but let's try. So let's go look at the random package and see if we can find a function. I already know what it is, but let's find the function in the random package that doesn't give us just any integer, but an integer within given limits. So I already know the answer to that question, and I'll just cheat and say it's this int n one. So int n takes one integer, but what does that do? It returns an integer, non-negative pseudo-random. Okay, so in the half open interval, 0 to n. So you may or may not have done a math class anytime recently where you used interval notation. But what the square bracket means is starting at 0 but not below 0. And then going up to and including n. Right? Or is it the other way around? Does this one exclude end? I guess we'll find out here in a moment. In the half open interval. So I suspect that the parenthesis means that it's up to but not including n. Yeah, so starting from 0 and including 0, going up to but not including n in interval notation. So we can get not between an x and a y, but we can get at least between a 0 and an x. And then we'll see if we can refine that any better with anything else in here. So let's improve with the int n calls. And let's just say something between 0 and 9, right? 10 would be one above. So if I put a 10 in here, what that just told me is I'll get random numbers somewhere between 0 and 9. Oops, I forgot to put the n on all of them. Okay, so 17791, 17791, 17791. So that handles part of our problem anyways. Now we are getting numbers in a range. We will actually, maybe we'll do that. We will make a function for ourselves that combines this with a little bit of math to get ourselves within a specified range. So let's hold on to that idea. It's a good one, Kevin K. So we're going to come back to it because I like it. But let's sort of get let's get the problem of the sequence fixed first. So the pseudo-random number generator doesn't produce random numbers. It produces pseudo-random numbers. What that means is that it generates a series of numbers, and if you don't do anything about it, you're going to get the same series over and over and over and over again. So the trick to making this a pseudo-random number is to somehow start in a different location in the series. So right now we're basically just starting at the very beginning of the series over and over and over and over again. So I'll go show you the function for this, but there's a function that allows us to say, I'm going to start in a different location in the series so that at least the numbers that spit out from that point on look different than if I just started right at the very beginning. So that function is this one right here, seed. So seed uses the provided seed value to initialize the default source to there's that term, deterministic state. If the seed is not called, the generator behaves as if seeded by 1. So let's just try that and see what that means. But the easier way to understand this is, so I'm going to seed from 1, and I expect to get the same sequence of numbers. And I did. And I did. So the better way to understand seeding is, at least in my opinion, is to think of it as an offset into that sort of never-ending series of random numbers generated by the computer. It's going to start in a particular place, but if we seed, meaning if we start in different places, then the numbers that come out at least appear different every time. So if I seed with 2, let's see if we still get 17791. Yes, so that's right. Kevin K has said it an interesting way in chat. You need to randomize your randomizer, as it were. That's true, yeah. Which is what the seed does. So notice I got a different sequence, but if I seed at 2, I get that same sequence. So if I seed at 3, I get a different sequence, but then I get that sequence. So changing the seed does change this, where I start in the series, and then does kind of create the appearance anyway that I'm getting, well, I am getting different numbers. And because I get numbers with different seeds, it makes it appear that I'm getting random numbers. So here's the thought experiment. I'll show you how to do it in code. There is something that we all experience in the physical world, and that is also true for the computer. Something that is constantly changing, even as we in the computer just sit here. There is something that is constantly moving, which is a tricky question. But does anyone, this is like a riddle. It's not a programming problem. It is a, if we can find something out there that is already a moving target, we can use that for our seed, which means that our seed will just kind of use that moving target to randomize itself. I'll give you another hint. If you look at the bottom right of your screen, probably on your desktop, or the top left of your phone, if you're on a phone, you will see the thing I'm talking about. If you are old school and it is on your wrist, it does something like this. Time. Nice one, Kevin K. Time. Time is always changing. So that's a great thing for us for doing pseudo-random numbers, because as time changes, if we seed with the time, then we are seeding with something that already changes by itself, which means that it will randomize our randomizer for us. Now, this code looks nasty, but this is just one of those things to keep handy because you need it to do pseudo-random numbers in Go. So we're going to use another package called time. So this is a library package. I'm not going to go look at it. I'm just going to show you how to use it. And we are going to use time as the seed. So we basically take whatever the time is right now, which every time we run the computer, run the program, time will have moved, which means that our seed will have moved, which means that our sequence of numbers will appear, will in fact be different. And then there's a little trick you have to do with it. Unfortunately, I know that part's nasty, but just sort of think of it as I'm taking the current clock time and then with a little adjustment in code. And this makes my seed follow the clock, which is constantly moving, which means that my numbers will constantly move and they will look a lot more realistically random than they would otherwise. So let's try it. 10324, 13927, 42557, 59952. You see how they're now a moving target. Why? Because the clock is a moving target. So that's great. Only ever do this once. So in a program, when you are using random numbers, you only ever do this seeding thing once. You don't repeat it. Repeating a seed can actually make the random numbers seem of a lower quality. So when you're writing a program that uses random numbers, you do this seed thing. You do it once and only once. And I always recommend that you just do it right at the top of the main function. Right here, once, only once. Don't do it anywhere else. Don't do it inside of any function. Don't do it anywhere else, but right here in main. And then your program will be able to use the random number generator and have the random numbers seem decent. All right, so there's a whole bunch on random numbers. This will be very handy for you on the second project because we have 2 play against the computer games, and the computer is going to be using random numbers for its play. It also opens up possibilities for a variety of other styles of game making, which can be fun if you're into that kind of thing. All right, random numbers from package rand. So we only really needed the 2 functions here, int n and seed. Okay, so now let us do Kevin K's idea. Let's make a function. I'm going to comment that out. I'm not going to do rand right now, so I won't need time, but I'm going to put math back. And let's do Kevin K's idea so that we can now take these math functions and use them to build our own functions that add on to their sort of built-in behaviors. So Kevin K has a very cool idea, which is get random number So we would like to have a function that Go doesn't appear to have. So we're going to write it for ourselves. We would like to get a random number that is in a specified minimum and maximum, and then return that random number in between that minimum and maximum number range. And then we would do something like this. We would say, I'll use the shortcut this time. Get random number, let's say between 10 and 20. So we'd like that to work. So let's go work on this, and then we will practice using math in conjunction with the math package in conjunction with our own function that will leverage. So we're going to use a random number, which means that we need to seed. And remember I said at the top of main and nowhere else, and once and only once. So rand.seed. Oh, well, that means I do need all this stuff. All three of them now. So rand.seed, I will seed to the current time and then do the little Unix nano-y thing, which is needed to get it to be a nice integer. Okay, so now we have a little math problem to solve. So the first thing to do is probably to get a number from between 0 and that maximum value. So let's do that first. So random number equals, and now we're going to use the math package, the rand package, int n max. So which will return any number between 0 and the maximum -1. So this is the way I work these things out anyway. So this is actually a tricky little math problem. It's not going to look hard, but it is a tricky little math problem. So how do I get a value to be between a minimum and a maximum? So as an example, let's say that I want between 10 and 20. And I want that to be inclusive. I'll use the interval notation. I want 10 and 20 to be possibles, right? So if I do rand.int n with the 20 part, the maximum part, I'm going to get 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say, oh well, I'm into it now. No, that's too many. Let's say 5 and 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I may not have the correct algorithm. I'm just kind of working on how would this work. Well, let's rewrite this so that to say what I want is 5, 6, 7, 8, 9, or 10. I need to... Okay, so can you guys see I've already got a problem? So the number of values that I should be dealing with, 1, 2, 3, 4, 5, 6 values. But if I use the maximum here, I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's a problem. Okay, so that is the number of values that comes out doesn't match the number of values that I want. So that's the wrong choice. What if I switch this to be the minimum value? So in this case, that would be a 5. I would get 0, 1, 2, 3, or 4. That's one too many. One too few, rather. Okay, well, how do I get one more? Well, I can say the min plus 1, which would be 6, which would give me all the way up to 5. Hopefully you're following along, but my first problem was, well, I need to be able to generate the same kind of quantity, or the possible range number in the range has to match. So if I need 6 possible numbers, well, I need 6 possible random numbers. So now those line up if I use the minimum value and add 1 to it. All right, so there's step 1. I figured that part out. Now what I have to do, if you will notice, is I have to adjust each of these. Basically, if I add 5 to each, I get 5, 6, 7, 8, 9, and 10. Aha! So if I add the minimum back, I get what I want. Now what's weird about this is that, do I even need the max? I do. Now I know why. Because if I change this, let's try a different example. So let's say that I want 1, 2, or 3. So the minimum would be 1, the maximum would be 3. So if I did rand.int n 2, I'm only going to get 0 or 1. So something is wrong here. If I just add 1 to the minimum, that is wrong. Okay, so that's not quite right. So, I mean, I know from experience because I've worked this problem out, but we have a little bit of time, so I'm just letting you watch me develop the algorithm. All right, so, but did you see what I did is I kind of went with just some handwriting problems. So this worked out for that situation, but if I wanted the values, if the min were 1 and the max were 3, that no longer works. So I need to think to myself, what's another relationship I can leverage here so that I have 6 values. I'm going to move this down, in fact. So this is between 5 and 10. This example is between 1 and 3. So 5. So now I have to think to myself, so min plus 1 does not work. Okay, so that's not the way to get this number then. What is the way to get this number right here? So what else kind of gets me in the ballpark here and here? Well, if I do the minute, I realize that I'm not using the max. So this 10 minus 5 is pretty close. And this 3 minus 1 is pretty close. So what if I were to say the maximum minus the minimum? If it were 10 and 5, that would get me 5, which is not enough. If it were 3 and 1, that would get me 2, which is not enough. But if I added 1 back to that, then I would have 10 minus 5 is 5 plus 1 is 6, and then this works again. And 3 minus 1 is 2 plus 1 is 3, and this works again. And then if I add the minimum back. Does this work? It does work. So I'm feeling pretty good about that. I'm going to do one more example. Let's say between 99 and 100. So what I want is 99 or 100. So my rand int n now would be 100 minus 99 is 1 plus 1 is 2, which gives me 0 or 1. So far, so good. Now if I add the minimum back, 99, I get 99 or 100. I am feeling pretty good about that. So I think this is the algorithm to get between a minimum and a maximum inclusive. Let's run a few tests and see if it works. So there's one between 10 and 20. Let's run off a bunch of these. And we'll just do between 10 and 20. I'm just going to use the function called directly on these. All right, let's see if we are getting, in fact, random numbers between 10 and 20. Did I not use math? Oh, I never use math. I just use random. So I'll show you the error. Do you see down here, imported and not use math? So in that case, just comment the thing out. Random number declared but not used. Oh yeah, dummy. So here's a function that's supposed to return an integer, and I never have a return statement. I do the math, but I never actually get to the point where I say return the answer. So they need the answer back in main, so I have to return it. So I compute the answer, and then I return the answer. That way it can be requested and used in main. All right, that run seems pretty good. There's nothing below 10 or above 20. That all seems pretty good. Let's write a unit test for it, shall we? So I can remind you what those look like and how they work. Okay, so unit test. You never have to write unit tests. I always write the unit tests. I'm just showing you how they're built again so that you're more familiar with them. So I'm going to import test here. Where's it testing? We will test get random number. And I'm going to do it this way. So you've never seen this before, but I'm just going to run off like a million of them and see if in a million tests. This is a couple of weeks from now, but what I'm about to do is I'm about to run a million random number tests, because there should never be a time when the random number is outside of my range. So we will have the result equals get a random number. I'll just go between 1 and 5. And if the result is less than 1 or the result is greater than 5, that's a problem. Yeah. So we'll print the message and then we will stop the test immediately. So we're going to try it a million times. If at any point I get a result that's outside, it's below 1 or above 5, then I will print an error and I will stop the test. That's what all that's doing. Yeah, let's run it. So go test star.go. So remember, it has to run 1,000,000 times. All right, so it never did break, and that doesn't mean that that's 1,000% guaranteed that the algorithm is sound, but it probably is. It's probably okay because I have tried it out and viewed the results, and then I also wrote a test to stress test it 1,000,000 times, and it ran through 1,000,000 times and never produced a number outside the expected range. So pretty cool. Okay, there's those things. What else do I have on the agenda? So I'm going to do the rest of this in the context of the lab. So I'll give you a couple of hints on the lab, and we'll probably get done a little bit early. So cool idea, Kevin K. I hope I didn't steal your thunder in implementing that, but it's a fun algorithm to generate on your own. So if you promise you, if you want to challenge yourself, just don't look at this code for a while. Let a couple hours pass. At least this would be true for me. If I let it a couple hours pass, or maybe 24 hours pass, and I came back to implement this algorithm, I might actually have to go through all the work again because I might not remember the details of how I did it. But anyway, very cool application of the rand function. Okay. But I also, it also gave me a chance to show everybody kind of how I might go about developing an algorithm by kind of just playing with some numbers and playing with my algorithm and seeing if it works as I change examples and then ultimately testing it out. Fun one to work on. So that, well, now I'm just going to have to share the whole REPL because I wrote a test in it. So I'll just put a link to the whole REPL out there. Okay, so now let's go look at the lab, and then we will probably finish just a tad early. So go lab 7. So let me get this all loaded up here. Need that one. This is main.go. And then I'm going to add a main underscore test.go. And then I'll go get that code as well. Okay, so we have a test. We have a main file. We should be able to immediately run this test. So I'm going to click run first. I don't think that there's any program in here. There's not. I'll go ahead and add one. I'll just make a little func main at the bottom that I can use as a sandbox. But you'll notice there wasn't a func main in this project because all we're doing is unit testing this week. So I recommend that you add a sandbox like this. It can make your life a little easier if you can play around with things. Imported, not used, math, rand, and fumped is undefined. So what's going on in the imports? Fumped needs to be added. Math and math.rand at present are grousing at me, so I'm going to disable them. And then fumped is grousing at me because I didn't have it in there, so add that back in, run my sandbox, and now it should say sandbox. Okay. What happens if I run the test? Do I pass anything? I might have passed some things. Let's see. Go space test space star.go space dash v to see verbosely what. Do I pass anything for free? Fail, 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 fail. I don't get any freebies. Okay, so I'm not passing any of the tests. Let's go find one. So I don't know if there's anyone in chat wants to offer one. I will wait for a second. So our options are, if you're in chat, you can say if you want me to. I'm going to do one of these. I'll pick for myself, but I'll let you pick if you see one you want to do. So I can implement area of circle. I can implement area of rectangle. Don't pick that one because that one's easy. You want to keep that for yourself. I can implement volume of cylinder. I can implement volume of box, also easy. I can implement distance between using the Pythagorean theorem. I can implement roll d6, or I can implement roll d20. So as I was scrolling down, if anybody in chat saw something they'd like to see us work on together. We can do so. And otherwise, I kind of have my two candidates that I think are the hard ones. Okay, so I'll pick, and maybe it was going to match anyway. I'm going to do distance between to show you how to do that. So the whole trick is, in all of these functions, is you compute the answer and then return the answer. That's the whole trick. Compute the answer, return the answer. You have to get used to the idea that when I am implementing a function, I don't care about anything else in the program. This is all I have to work with, and I need to get my solution out of only these things. Now, these notes up here are telling me what's going on and giving me hints. So I have 2 points, an x1, y1 point, and an x2, y2 point. And this is referred to in the notes. So compute the distance between those 2 points. Return the computed difference. It recommends that we use the Pythagorean theorem for distance. And it also hints that we might need math.pow and math.square root, which sounds kind of nasty. So let's go look it up. So Pythagorean theorem, distance. Okay, formula, I'll take it. I'm going to click on this because that picture seems like it is clipped. Here it is. Right here. So the answer is the square root of x1 minus x2 squared plus y1 minus y2 squared, and then take the square root of that. So this one we won't need. So that's a good question, Kevin K. Do we need the absolute value function here? And we won't, because the squares deal with that problem for us. So because we're squaring the differences of the x's and the differences of the y's, we don't have to worry about absolute values because the squares eliminate that problem. But good to note. Important to note. Okay, so x1 minus x2 squared added to y1 minus y2 squared, and then the square root taken of all that stuff. So here's how I would do that. And then I'll show you kind of 2 ways to do it. Let's do it the long way first, which is the x difference. I'm just going to call it the x diff. So the difference of the x's is x1 minus x2. The difference of the y's is y1 minus y2. Okay, so all good there. Then I can say the x diff squared. Now we need math. So let's go get math back. Need math. X diff squared is math dot pow, the x diff raised to the power of 2. So we're using the pow function from math. We could go look at that here if we wanted to. I still have the documentation open. Math.pow returns x raised to the y. So you give it the number and then what you want to raise it to second. All right, so there's the x diff squared. Let's do the y diff squared equals math.pal, the y diff raised to the 2. So notice how I'm tearing this down to just its, so I just deal with the differences first. Then I deal with squaring those computed differences. The next thing is to add them together. Plus y diff squared. So that's the next part. And then the answer, or I could say the distance, is the square root, that's a math function, of the xy stuff combined. That's the answer. And then what I would return is that computed distance. So you compute the answer, you return the answer. This is by far the hardest one to do. And if I did it right, I should be passing some tests now. So I think I need to run this first. Well, let's see. Maybe I don't need to run it, but I feel like I need to run it. Oh, no. Oh, no. That might have wiped out some of my work. It did. Don't like it when that happens. Let's run it, and we'll just see my sandbox. But also, I'll see if I get any kind of just basic kinds of errors. Okay, no kind of programming errors. Now let's see how the test goes. Go space test space star.go space dash v. Please let me pass some. I passed one. I passed the distance between tests, so I'm on my way. That worked. You can, by the way, I like to break my problems apart like this, but you can also long form. I'll do the short form and show you how that works. The short form is the distance equals the square root of the square of x1 minus x2 raised to the power of 2 plus the square of y1 minus y2 raised to the power of 2. So I could do it this way as well. I'm less comfortable with this kind of compressed style, the short form. But you can do it if you're comfortable with it, because if you understand that Go has to work from the inside out, so it sees this big old nasty thing, well, it has to go inside of here and work from the inside out. So it actually, and then if you see there's an x1 minus x2 inside of there, which means that Go has to actually go on the inside and work its way out from there. So Go has to do this part first, then it can do the PAL, then it has to do this part, then it can do the PAL, then it can add them together, then it can take the square root. So play around with that. Neither one is better or worse. I like to spread it out because I understand it better. But I don't have a problem reading it squished together. I just find it harder to develop the solution with it squished together. I can read the solution if it's squished together like this, but I have a harder time implementing that. So totally your choice. I'm going to put the long form back. So there's the distance. That's the hard one. That's probably the only one that you need. Volume of the cylinder, you look it up and then you convert. So compute an answer, return the answer. Just Google, or for me, because this Microsoft browser works better in Canvas for some things, it would be a Bing search by default. But anyway, volume of a cylinder. It's pretty straightforward. Pi, which is math.pi. So use math.pi. Don't use 3.14. Use math.pi. And pow. That's all. Right? So math.pi times the math.pal radius, comma 2 times the given height. You can compress it short form, or you can stretch it out long form, up to you. So anyway, that's I think what I got for this week. I hope it is enough to arm you with what you need to solve these problems. I did the nasty one. I will put this in my stuff to share with you on the lecture page, so you have at least that one solution to work with. The sandbox, by the way, actually I'll reply. The sandbox doesn't affect the test at all, so you can just kind of you can just do your own experiments here apart from the unit test. So you can take, and you can literally just do it like distance between 0, 0 and 10, 10 is percent. Is that a float? Yes, it returns a float. Percent 0.2f will say. If it gets too long, then just drop it down to the next line, and I will say distance between x1 is 0, y1 is 0, x2 is 10, y2 is 10. And then I can run little experiments. Apparently that distance is 14.14. So you have this, you can create for yourself this little sandbox, and it won't affect the unit testing, but your goal is to pass the unit test. Don't forget. Okay, let me update that and then say good night probably. Yeah, so that's everything. Hopefully you are becoming more comfortable over time with these things. I know it's hard, and I wish there were sort of any kind of magic that could be offered to help you, but there isn't. It's just practice. It's thinking. It is sort of trying to craft a story in your head about what's going on between these functions. Yeah, it just takes work, takes time, takes practice and exposure and patience. So my best wishes that your labs go as good as they did last week, because they appeared to go really, really well. And then starting next week, we can start having a lot more fun, because we'll have decision making and all of the other tools that we've accumulated for ourselves over the past, by then, 7 weeks. And we'll start sort of a sprint into the second project. So I hope you have a good night. Hope you have or are having a good week, and I will see you on Tuesday afternoon next week. So take care.